Okay, so I'll show you both methods, right? So let's talk through factoring first. That would be my preference. Okay, so if you're going to solve this by factoring, what you want to do is you want to look to see you have these two groups of factors here. Okay, so let's look at each group, and really you can just start with the smallest group because that has the fewest number of distinct factors to choose from. So let's take number-wise. Okay, this one has a factor of 2. This one, the numerical factors are 1/2 and 8. Well, we can simplify that. What is 1/2 of 8? Just a 4, right? So between 2 and 4, what common factor can you remove? 2. And let's go to our next base, the 4x squared plus 9. That's a common factor to both groups. So we're going to take out the smallest power, which is what? The negative, right? And so whatever's left has to have the exact same form as the original. So the original was one group minus another group, which you guys see the pattern there, right? Almost all of them are like that, right, that you've seen so far. But it has to have that same form as the original. So let's see what's left. We took out a 2. We took out a power of minus 1/2, so we subtract that out. Minus a minus 1/2 is equivalent to adding the opposite. So in this first group, all we're left with is a 4x squared plus 9. And now we go to the second group. In the second group, when we take out a 2, so again, this 4 becomes a 2. We're left with a 2x, 2 times x here. We take out a power of minus 1/2 here, which is equivalent to adding the opposite. So in effect, we took out that entire factor of 4x squared plus 9. So we're left with this 2x plus 3. And then this is all over 4x squared plus 9. To the 1/2 to the second, when you take a power to a power, you do what with the powers? Multiply. So 1/2 times 2 just is 2/2 or 1. Okay, so as we work to continue simplifying this, we have a negative power here, so this whole factor can get moved down into the denominator. Bless you. Bless you. And so that moves down into the denominator, and then we can simplify what's up here. So we have this 2 times, here we have 4x squared plus 9. We distribute the negative 2, or the negative 2x, so we get minus 4x squared minus 6x, and that's all over. And here we have a common denominator, a common base, so we can add the powers. 1/2 plus 1. Again, 1 is equivalent to 2 halves, so you get a total of 3 halves. All right, if we simplify what's in our parentheses, or continue that process of simplifying, the x squareds cancel. And so we can either leave it as 2. Now, let's talk about the different forms that you can have here. All right. When you write your form, you either need to be written as factors or written as a polynomial. You can't have a mix of both. So what's missing from this? If you leave 2 out as a factor, are there any other factors you can remove from this? Yeah, 3. And even more ideal, a negative 3 to get the leading coefficient to be the variable. So let's say I take out a negative 3 from both of these, so that gives me a negative 6 out front. My 9 becomes a negative 3, right? I'm factoring out a negative 3 from each one. And my negative 6x becomes a positive 2x. So here would be one of my potential forms. Okay, so you can write your answer as factors. You could also write your answer as a polynomial. So if you write it as a polynomial, our steps from here would be to distribute our 2. We get an 18 for our number, and then a negative 12x. I write the x's first. Now, here you can have a negative as your leading coefficient because you're not writing it as factors, you're writing it as a polynomial. Okay, so either of these two forms is going to be okay. All right, let's take a look at what happens if you're going to approach this as a complex fraction. Right, if you're going to approach this as a complex fraction, what you want to do, and it's probably easier just to convert everything to radicals, although you can leave your rational powers. I'm just going to write it as a square root. So we have 2 square root of 4x squared plus 9 over 1. Again, each individual piece needs to be considered as its own separate fraction. So there's my first fraction, and then here's my second fraction right here. So again, the 1/2 and the 8 reduce, so I get minus, I have a 4x times the 2x plus 3 is a positive power, so it stays in the numerator, but my negative power, the square root of 4x squared plus 9, gets moved to the denominator. So here's my second fraction, written again as a single fraction by itself. And then in my denominator, the half and the 2 cancel, leaving just my 4x squared plus 9 to the first. So I'm going to write that as a fraction also. Again, if you're going to solve it as a complex fraction, you need to express everything in terms of fractions. Okay, so now you can combine the numerator into one single fraction here. Our LCD is going to be square root of 4x squared plus 9. So we're going to take our first fraction's numerator, 2 times root 4x squared plus 9, times the LCD factor that's missing from the denominator. What's missing there? The root 4x squared plus 9. So again, repeated multiplication is like squaring, and the square and the radical will cancel. So you're just left with the expression that's inside the 4x squared plus 9. Minus the next fraction, numerator, 4x times 2x plus 3, times any LCD factor missing from its denominator, not missing anything. Okay. So if we continue to simplify this, we'll distribute our 2 here. So we get 8x squared plus 18, distribute our negative 4, minus 8x squared minus 12x, all over root 4x squared plus 9. So here our 8x squareds cancel. We can now invert and multiply. We're taking this whole expression, 18 plus 12x over root 4x squared plus 9. And instead of dividing by this fraction in the denominator, we're going to multiply by the reciprocal, 1 over 4x squared plus 9. And now we can go back, turn this back into the rational power, and combine our terms. Here I'm just going to reorganize these terms. And in the, oops, this is a negative 12x, I'm sorry. We come back here on the distributing, this should be a negative, which makes this a negative. Okay, so you get, when you simplify here, your 4x squared plus 9 to the 1/2 times, or power of 1/2, power of 1, add their powers, and you get the same thing. So it doesn't matter which form or which method you choose. Okay, all I'm